Dear Chopper.
Hi, Mr. Fernandez. This is my video for our AP Physics final project. Levi told me his video was 12 minutes long and he recorded it in a Zoom session. So I'm gonna try and make this as entertaining and brief as possible because I don't want to bore you. Basically, inspiration for the idea was I thought railguns and coilguns were cool. They're used by the military, people can make them at home. And so when I started the project, I started by creating like a super mini coil gun with a disposable camera capacitor, which was pretty cool. It barely shot, but after sort of figuring out the basics of the circuitry, which took actually a long time because troubleshooting was hard, I just decided to upgrade the hardware. So I bought some new capacitors. This is one of them. I brought them into school to show you guys when I had them shipped in. And then, yeah, so initially I actually wanted to create like some sort of like actual weapon that I could like come in and do show and tell and like be like, here's my cool like coil gun projectile launcher, and like could actually shoot it pretty far. But after like doing like some hours of work, I realized it was gonna be a lot harder than I thought, because the way coil guns are actually made is a little more challenging than what I would have expected. So this is what it looks like right now. It doesn't look like much of a gun at all. It looks like a pen with a bunch of enameled copper wire wrapped around it, which it is. And instead of shooting, so like, where's my armature at? This is the one I actually used, 50 millimeters, not millimeters. Put it in one end, and when I activate the system, which I'll show you here in a second, it oscillates towards the center like this, because you know, when you pump a bunch of volts through this enameled copper wire and it goes around and around and around, it creates this super strong magnetic field, electromagnetic field, that draws all the magnetic objects to the center of it. So the way a coil gun would work is that it would go like this, right? So it'd get accelerated towards the center really fast, and then there'd be a sensor like right around here that would detect the projectiles passing through, and it would shut off the current, right? So that way it would accelerate super fast, and then it would shut off, and then it would keep going. However, in my experiment, because I don't have the hardware required, like I need an Arduino and some sensors, it just oscillates towards the center. However, I can still pick up the initial velocity as it travels and accelerates towards the center of the electromagnetic field. So just as a little demo here, I have my power supply set to 30 volts, which means 30 volts is running through all 4 capacitors. I have my little doorbell switch here, and you can see on this side, you can see the little metal armature, and then when I press the button, it shoots towards the center and might zap me a little bit. And then I can try it with a longer one just to show you the same effect. So if you look, you watch, you can see it peeking at the end, and then when I press the button, and then when I press the button, nothing. Oh, so during that demo, I accidentally busted a wire, and I'm gonna have to solder it back on. Oh, I love that smell. I love inhaling toxic metal fumes. All right, let's put that away before I start another house fire. Okay, so with what I was working with, my experiment, the goal was just testing the relationship between capacitor charge and the projectile velocity, so towards the center, just to gain insight about the physics behind coil guns and electromagnetism. For my materials list, power supply, the 6 capacitors like I mentioned, plastic pen, pencil, enameled copper wire, which I have 2 coils of here in case I wanted to do a 2-stage coil gun in the future, a metal hanger, right, which I chopped up and then used for projectile ammunition, the doorbell switch, which is kind of sad and I don't want to pull it off the circuitry here, but I don't think it can handle that much voltage, so in the future I should probably get a stronger switch. Safety goggles, which are important because sometimes capacitors explode if they're overcharged, a soldering iron like I just showed, a vise, which is important for holding a lot of the materials, and then some sort of measuring device. I have a caliper here, which I know is for like measuring specific objects, but it still has millimeters on it, so that worked better than a tape measure for me. And then a voltmeter too is also important because I wanted to make sure that my capacitors were fully charged. And then to strip the enameled copper wire, I have wire strippers here, but you could also just use like scissors or like a blade. So to build the thing, I just removed the internals from the pen pencil casing, leaving the plastic tube. I used electrical tape to tape the 6 capacitors in parallel and wire them together. I then wrapped the enameled copper wire around the pen case to create a coil. I actually used like a fishing reel to like make it really fast. I connected the capacitor bank to the doorbell switch. I then stripped and soldered one end of each end of the coil to the capacitor bank, and then soldered the other end to the switch to control the circuit. And then I cut off the piece from the hanger. And then for the actual data collection, you can see I put the caliper on top of the vise just so I can position like in millimeters on top. And then what I did is I put the projectile and everything on the vise, got it all set up. I started recording in slow motion, press the switch right to actually launch the projectile towards the center of the electromagnetic field, and then turn off the power supply, press the switch again to discharge it, and then recorded the data using time and position. And then this is what my data looked like. So as you can imagine, as the supply voltage increased, you saw an increase in the output velocity. It wasn't like perfectly consistent, but what I found is that the LNX function actually fit the graph pretty well. And I imagine is like the more I increased it, like it would get closer, it would like approach this sort of like 1 meter per second mark, kind of like that. And I don't want to bore you by reading out my entire CER, but as the capacitor charge increases, the armature velocity increases. The data collected clearly demonstrates a correlation between the capacitor charge and the armature velocity. Increasing the capacitor charge in 3-volt increments resulted in a consistent increase in the output velocity. So like at 0 volts, obviously it didn't move at all. And then at 30 volts, it moved 1 meter per second. So that's pretty strong evidence. Yeah, and this just sort of aligns with the principles of electromagnetic acceleration. So like, and then like for the boring math stuff, there's a couple equations that are relevant. Number one is the equation for like energy stored in a capacitor, which is E equals 1/2 V squared, or sorry, E equals 1/2 CV squared, C being capacitance. So these capacitors, I don't think it's actually written on here, are 470 microfarads, it's somewhere on there. And then another relevant equation would be Newton's second law, F equals ma, which relates force, mass, and acceleration. And as the capacitor charge increases and generates a stronger magnetic field, the force on the armature increases, and consequently the armature experiences higher acceleration, resulting in higher velocities. So there's the math. And like kind of jumping into the reflection actually quickly here, is like, there's not a consistent velocity, right? So like it's not moving at like a consistent speed of like if it was a car going 60 miles per hour, but it's accelerating, right? This magnetic field is accelerating this projectile really fast to the center, so it's gonna go slower than fast. So my recording of velocity, like that could have been like one of the flaws in the experiment. And in hindsight, like I had some of the LabQuest materials, but because it wasn't launching out, it was really hard to set up the sensors to detect the projectile like oscillating back and forth. I tried, but it didn't really work. So I used my camera. So like in the future, if I were to build like an actual railgun, like I'd mentioned, ideally like a 2-stage one, so it could go through stage 1 and stage 2 and really accelerate fast. With the sensors that would be required to build that, I could actually have like an internal velocity tracker, and then that would have made this experiment way easier. So I would need an Arduino to do that. Like other stuff that like could have caused issues is like my measuring system wasn't the best, right? Like I had the caliper like wedged on top of the vise, and I used the video for reference, so like that was sort of iffy, but the data looked good. It makes sense, and I think I learned a lot about electromagnetism, electrical engineering, and how to build your own personal weapon at home. Thank you for watching this video. I hope it wasn't too boring, and I tried to hit everything on the rubric. Please give me a good grade. I need to do good on this project, or I will get a bad grade in this class. I need a 190 out of 200, Mr. Fernandez, please.